Okay, in this presentation I'm going to be going over differentiated services. Differentiated services are on the opposite end of integrated services, which use RSVP for communication. Integrated services are also flow-based. Flow-based algorithms have many downsides. Some of these downsides are that they require advanced setups per flow, and this is difficult when there are thousands or even millions of flows. They're also vulnerable to router crashes because it needs end-to-end communication between the two routers. They're also complex to set up with the router-to-router exchanges. On the other end of integrated services, there's differentiated services, which aren't flow-based. Differentiated services are a standardized architecture for class-based quality of service. Differentiated services can be largely implemented as they don't have the downsides of the flow-based algorithms. Customer packets are marked to a certain class, and these classes are treated with different priorities. Better service from the router is provided to packets with higher classes, giving the ones with higher classes a difference in delay, jitter, and probability to congest the flow. The ones with a higher class will have a lower chance of delay, jitter, and probability to congest the flow, while the others have lower and lower. There are many different ways to classify these different types of classes when talking about differentiated services. One of these classification systems is expedited forwarding. Expedited forwarding is one of the simplest kinds of differentiated services. It's simple because it only uses two classes, one regarded as regular and one regarded as expedited. The majority of the packets that are sent are labeled as regular, while a select few are labeled as expedited. Expedited packets should go through the network as if there are no other packets present. You can see that in the image below, where expedited packages are sent one by one with nothing else in the flow, while regular packets are sent normally. While this image does show two separate lines, they both go through one physical line, this being the same line as this. Expedited packets are given priority over regular packets. So once an expedited packet comes into the system, it's sent first and without any other packets present, while the regular packets are then sent afterwards altogether. To implement this, packets are labeled as regular or expedited by the sending host or first router, and then received by the next router. So the expedited ones will be labeled accordingly. Assured forwarding is another type of classification when it comes to differentiated services. In assured forwarding, there are 4 different types of classes: gold, silver, bronze, and regular. These are set by the sending host. These are also known as priority classes. Each class, gold, silver, bronze, and regular, is then broken down into subclasses of low, Each class is broken down into subclasses of low, medium, and high congestion rates. This is also known as a discard class. So the gold would have a low, medium, and high discard class, as well as silver, bronze, and regular having low, medium, and high discard classes. This discard class is set by the traffic policer. An example of this is the token bucket, which was went over earlier in the presentation. This makes a total of 12 different service classes, with gold having 3, low, medium, and high, silver having 3, bronze having 3, and regular having 3, which makes a total of 12. Both these priority classes and discard classes are encoded into the packets. After this has been encoded into the packets, a weighted fair queuing is used, with the higher priority packets getting more weight, and also the congestion rates differ among them, so it is sent accordingly. Those are two different types of differentiated services, while there are many different other classification systems when it comes to differentiated services. Next, I'm going to be talking about internetworking. Internetworking is when two or more networks are connected. A prime example of internetworking is the internet, where your network can send data to any type of network worldwide. It's not always simple to get packets from one type of network to another type of network, as they might differ slightly or even drastically. The physical layer is not that big of a concern when it comes to the differences in networks, while the network layer is a bigger concern when using more than one network type. Some of the key differences are noted as below. Some network layer differences are the service offered. Some use connectionless, while others use connection-oriented networks. Examples of this is Ethernet-oriented networks to WiMAX-oriented networks. Addressing is also another concern, with different sizes of addresses. They can be flat or hierarchical. Broadcasting is also another concern because it could be present or even absent in different types of networks. So sending packets to multiple different receivers could be able to happen in one network while it's not able to happen in another. Packet size is also another concern, with every network having its own maximum and minimum. So sending a packet that's bigger size than the receiving network's max could cause some issues. Ordering is another big problem because some networks order their packets differently, and it could be sent and received in different orders. So the packets being sent won't be received the same way as they were being sent. Quality of service is also another concern when it comes to internetworking. Quality of service can be present or even absent in different types of networks, and there are many different types of quality of services. Reliability is another key difference between networks, with different levels of loss between networks. Security is a main concern, as there are different privacy rules, encryption, and other things when it comes to different types of networks. Parameters, there's different timeouts, flow specifications when it comes to different networks, and accounting by connect time, packet, byte, or not at all. Some of these differences require new connections or even setups, adding delay to the connection. And now my question to the class is, what is internetworking? And what is a prime example of internetworking? The answer to this is two or more different types of networks being connected, and the prime example would be the internet. Thank you, and have a nice day.